Welcome to A Basic Introduction to Mechanical Ventilation. This is Chapter 3.1, Pulse Oximetry. The pulse oximeter is one of the most important monitoring devices. It sits up there with the blood pressure and the cardiac monitor. This provides a continuous assessment of the oxygen saturations that's very accurate within the range of about 80 to 90%. In that range, the error rate is about 1 to 2%. Once you go below 80%, however, the error range becomes a lot more problematic. And once you're below 60%, you really don't have an accurate oxygen saturation. Although you also have a bigger problem on your hands than the accuracy of the oxygen sat probe. Pulse oximetry uses photospectroscopy, which is really a long way of saying the probe measures the absorption of light. This is the same idea as how we see color. Whether the light source is natural, like from the sun, or from an artificial source, all white light is a jumble of light waves of different frequencies or wavelengths. When light hits an object, some of the light waves are absorbed and some are reflected. If the object is green, for example, the light waves in the green spectrum of wavelengths are reflected and the rest are absorbed. The green reflected light then hits the back of our eyes and our retinas detect the color. This is how we know that the object is green. Now, a pulse oximeter is a light emitter and a sensor. This is why it's usually fashioned in a clip so that the light emitter can send the light directly towards the detector. The light emitter sends out light in two different wavelengths, one for oxygenated blood and the other for deoxygenated blood. The light then passes through the tissue and is absorbed by hemoglobin, depending on whether its wavelength is specifically absorbed by oxygenated or deoxygenated blood. The light that then makes it through is detected by the sensor. The monitor then compares the amount of light sent out and received and calculates the oxygen saturations based on that. There are many benefits to being able to monitor continuous oxygen saturations. In fact, they should be pretty obvious to you by now. But there are some limitations on what a pulse oximeter can tell you about the patient. It cannot tell you if you're giving too much oxygen. Now that seems like a little bit of a ridiculous statement, but in fact too much of a good thing can be bad for you, and oxygen is no different. In neonates, too much oxygen can cause blindness. In adults, it can cause lung injury, especially when the patient has ARDS. The reason the pulse oximeter cannot tell you that you're giving too much oxygen and overdoing it is because the oxygen hemoglobin dissociation curve. On this figure, you can see that once the oxygen saturations are 100%, there's a long flat line where increasing the oxygen delivered only increases the amount dissolved in the blood, the PaO2. This extra oxygen is not needed because the oxygen saturations are already maximized, and now this extra oxygen can cause all kinds of mischief. It goes without saying that the pulse oximeter is unable to measure the PaO2, and you're going to need to use an arterial blood gas in order to measure that. A pulse oximeter is also unable to measure ventilation via the PaCO2. Fortunately, however, we have another device that can help us, and we're going to discuss that after the next video.